let's go. We're doing homework because I'm bored. Yeah, that's about it. I don't even know if there's anyone in. I don't really care. I'm gonna do this later. I don't know, but I want to see how this goes because I have an idea. If I can like make the live stream and like instead of having to help each individual person, all I can do is just send them the link to this so they can go through the live stream and see like how I worked this out. Like low-key, that might be a new way of like tutoring and stuff. I don't know. Let's see how it works, and then if it doesn't work out, then it doesn't work out. But if it works out, then it works out. Okay. First up, let's see. What the hell? What was that? There we go. Wow, good. Absolutely no views. Okay. I don't care. AP World History, I guess. AP Physics, Golanus. Yeah, let's do that first. Okay. YouTube. Just go to regular YouTube. Heimler history. Can I even? God, I don't care. It's just something that Opera does.
Oh, you want to talk about the processes that initiate and drive?
I don't know why it's getting mad at me for having an ad blocker when it's just something that Opera does. Like how can I control that? Okay, let's do this. Falling ball unit 1, 2, AP Physics 1, my flow. Is this even on? Hold on. Yes, tomorrow is 8A, Jaden. Do you need help with the what do you call it? Do you need help with the homework, Jaden? Is that why you're here? Wait, are you still? You're still A-Day, right? You're still A-Day physics? Aren't you A-Day physics? I'm like 20% sure you are. I'm pretty sure you're A-Day physics, aren't you? Oh, lucky. Oh my god. No, that's oh, that sucks. That sucks, but I mean, yeah. So you haven't gotten this yet? Okay. Some physical quantities, like, here, let me see if I can find it so you can actually see what I'm doing, because you're probably going to have to do this later. Force vectors, and trigonometry, AP Physics paper. Doesn't Galanis, like, make every single thing that he gives us? I thought he did that. Yeah, no, he makes every single thing that he gives us. It's crazy. Okay, well, now I have to do this. Hold on. Okay. Let's break this apart. Trash. Okay. This is what we got today. So let's. Can I view this full screen? I have to download it. I have to download it to view it full screen. Download. I can just open it with something. Preview. Open with preview. I don't know. I just downloaded it either way, so it doesn't matter. Okay. So here's the first page. Let's zoom in. Okay, some physical quantities like time, mass, and speed are characterized by having only a size. It's not due to Tuesday? Lucky. Refer to as magnitude. Such quantities are called scalars. Other physical quantities like displacement, velocity, acceleration, and force have both magnitude and direction. Such quantities are called vectors. Previously, we have been able to indicate the direction of the velocity or acceleration by using positive and negative signs because we only consider motion along a straight line. Okay. Much of our study focuses will be two-dimensional, requiring us to be specific when indicating direction. We must also be careful when adding vectors in 2 dimensions. To form a vector sum, we need to be able to coordinate axis to line. Then vectors along each axis can be added. Okay, so that's pretty easy. It's just saying vectors can be added together whenever they're on the same coordinate. To align a vector with coordinate axis, we represent a vector at an angle 0. So like this, or not angle, that's a theta, I think. Is that what, Jaden, what are you saying? I'll just do it tomorrow. I'll just watch this and then you'll be able to do it. Jaden, do it with me. Think about that. You can just do it with me. Bam. Oh my god. Huge amazingness. Yeah. How many people are watching this? I don't even know what songs. You should do it with me, Jaden. Don't be a loser. Don't be a lame person who doesn't do their homework. That's mean. It's very, very mean. Because then, like, you're cheating yourself, man. Inspiration. What does that even mean? Okay. Angle theta with the horizontal x-axis, such as A on the right, so this one, with 2 component vectors. So this is one component vector, A, and then AX is the other component vector, I'm guessing. Oh, AX and AY. Oh, okay. So AX, these are the 2 vectors that we have, AX and AY. So hold on, let me see, where is it? Edit with, where's all your photos? Yeah, here, there we go. Perfect. Okay, so, oh my god. It's gonna be, let me just, Microsoft Paint. Hello? Oh my god, why do you have to be like this? Cancel. Okay. Can I open this in Microsoft Paint or something? Oh, okay. Hello? Zoom? Excuse me? Okay, here we go. Okay, so, basically, AX, AY, those are the 2 vectors we have, and we're trying to find A, which is the hypotenuse, and the angle in which it is like above the x-axis. Because whenever we have this, we can actually say something like, oh, we don't just have to say angle A or vector A is going northeast. We can say that it's going exactly 37 degrees above the horizontal x-axis, because apparently we need to be specific whenever we're doing physics, because yeah. Okay, whose sum is the same as the original vector. Each component vector is aligned along one of the coordinate axes. These component vectors are perpendicular to one another, so they're talking about ax and ay because they're perpendicular. Again, what's it called? Okay, sorry. Each component vector is aligned along one coordinate axis. These component vectors are perpendicular to one another. Again, since ax and ay are not in the same direction, adding their magnitudes will not give you the value of the magnitude of a. However, this is a right triangle, so we can use some simple trigonometry to find the magnitude of ax and ay. Hold on, let me send the link to people so that they can like, you know, get help if they need it. But I can already see what they're trying to like do, like what they're trying to get us to do. They're just like, this is probably going to be a huge thing about how we need to use the, what do you call it? We need to use the whole what do you call it? Where you have to use the whole a squared plus b squared equals c squared to get the hypotenuse, because that's what's important, you know. And it's gonna help us. Oh no, I'm sending the link out just to a few people, see if they need help with it. And then I don't think I'm gonna do the other homework like on here, because to be honest, that one's just writing down notes, so that's not very like. Yeah, it's due tomorrow for us. Yeah, we both have ring. Yeah, you need to do the ring homework. Do that. That's the important homework. Who else has Nathan Santos? Do you think he'd watch? Does he even care? Okay, well, here, Jaden, start doing this one because this is important. And yeah, whose sum is the same as the original vector. Each component vector is aligned with one of these components. Okay, since ax and ay are not in the same direction, adding their magnitudes will not give you the value of the magnitude of a. Okay, it's very important. Since they're going in two opposite directions, obviously, you can't just add them together to find what this is, because you're basically it's like if you, they're not the same, they're not going in the same direction, so they're not going to give you an average. They're just going to give you a random number that really has nothing to do with it. What you're trying to do here is find the average direction that whatever this thing is traveled in. Instead of going boom, boom, you're trying to find from point A to point B, what's the average direction it traveled, how far did it travel, and in what direction did it travel. That's basically what we're doing right now. A little simple explanation. In a right triangle, the side next to the angle is called. Okay. I'm cooking right now. Okay, so yeah. In a right triangle, the side next to the angle is called the adjacent side. The one across the triangle from the side is called the opposite side, and the longest side of the right triangle is called the hypotenuse. Hypotenuse, opposite, adjacent. If you took geometry, you're going to remember this. In order to find the component vectors ax and ay, oh, this is also going to be important. Remember this. Sin, cos, tan, SOHCAHTOA. Saw, as in SOH, saw, C-A-H, ka, and then T-O-A, toa. Saka, toa. In order to find the component vectors ax and ay for vector A, we can use the trigonometric relations from above, cosine, all that stuff. This is just, what do you call it? Freaking, this is just basically like, okay, so in order to find the component vectors for vector A, we're going to use trigonometric relations from above, like I said. And basically, since the cosine times the angle is equal to all this, if you're trying to find the hypotenuse, which is A, all you have to do is rework it. Well, in this case, actually, they're trying to solve for A of x, which, all you got to do, it's like algebra. You just got to move the equation around so that you can solve for the thing that you want. Now we can plug in the magnitude for vector. That's what I just said. So this entire page is just telling you how to do it. Pretty easy. Now let's actually start, doing it. Get out of that, and now let's go into the other thing. Where is it? Here it is. There it is. Okay, here's the actual math part that we're gonna need to do. So I really need to figure out how to draw on this thing. How do I do this? How do I draw? How do I draw? Paint. Microsoft Paint. Do I have it? Paint. Yes, I do. Open. Come on. Let's do this. Okay. Oh, wait, no. Cancel. Edit. View. File. Here it is. Import to canvas. Image properties. Share. New. Image creator. Layers. How the hell do I do this? Can I just insert up image, please? Please. Here it is. This one. Open. Yes. Okay. Oh, this is gonna be so. Let's zoom out a little bit. Come on. Here we go. Oh, not that much. No, zoom in. Let's zoom in. F11. Okay. Oh my god. Oh, this is gonna be horrible. Oh, why is the latency so... Why is it so laggy? What the hell? Hey, color. Okay, it does work. Okay. So. Okay. So right here it says draw and calculate the value of x and y components of the given force vector. Okay. So. X and y components. So we already have, this is theta right here, this angle right here. Oh, I need something a lot thicker than that. That does not sound right. Brush. Hello? Okay, yeah, that's a lot better. Okay, so this angle right here, this is angle theta, this little weird zero looking thing. This is the hypotenuse, so like A in the example, this is A. And then what they're asking us to look for is A of x, or like what, so A of x, and oh my god, I feel like Mr. Galanis, bro, not in a good way. I don't think there is a good way to feel like Mr. Galanis. and a of, oh, that's a horrible color. Oh, that's a horrible color. And a of what do you call it? Y. A of y. We don't have these, and we're trying to look for them, but we do have the hypotenuse and we do have theta. Now that's very important because if you look back at your first page, at the very bottom where it says sine, cosine, tangent, all that stuff, you are able to see that we can find these just with these. So, yeah, it's pretty easy. Pretty easy. We got this. So, first of all, let's find a of x. So this in relation to this angle, this is the adjacent because it's actually touching the angle. So a of x is the adjacent. So we are going to be using cosine theta, which is here. Let me just see if I can. Cos theta is equal to the adjacent, which in this case is a of x. Adjacent. Oh my god, it's so hard to draw like this. Adjacent over hypotenuse or just ax over what do you call it? A. Now all we gotta do is plug that in. So cosine, all that stuff. And since we're trying to find this, all we have to do is rework it into, I'm not changing colors for this, just deal with it. All we have to do is rework this into an equation where we can basically solve for a of x. So to do that, this has to be by itself. Right now it's being divided by a, so we just multiply this by a, cancels this out, and multiply this by a. So this is equal to a of x, what we're looking for right now, is equal to a, or 450, times cosine of theta. Now if you plug that into a calculator, I don't know if I can show that on here. I guess I can just do it in Desmos. I love Desmos. So easy. Okay, so if we do that in Desmos, here, let me see if I can just, I don't know if I can actually. Oh, yeah, I can. Okay, so this is what we got. Now if you plug that into Desmos, functions cosine times whatever theta is equal to, which in this case is 50, cosine of 50 times a, which is 450, I believe. 450? Yeah, it's 450. Times 450, we get 434.23. I always like to round up to the second, and it doesn't really say anything here, so I'm going to just round up to the second. So this is equal to, officially, 434.23. Let's say m. Is that meters? That's an. I think that's an m. Hold on. It's an n. N for newtons, I think. Or, oh no, newtons probably. Doesn't really make sense though. But yeah, 450 newtons. This a of x is equal to 434 newtons, and then if I'll write out the steps for this one too. So here, I'm about to erase this. So if you want to make like if you want to take screenshots, or well, I mean, I guess you can just rewind. So yeah, let's see, got it. What? Did it just erase everything, including the background? That's actually diabolical. Oh my god. Why would it do that? Wow. That's not very nice. Selection. Keep the stream up. Okay, I'm not reading that out loud. Okay. Erase. Oh my god, what is this? No, what is this? What is it doing? What is this? What is this? I don't like it. I don't like this. Wait, no, just stop. Stop what you're doing. Stop. Okay, well that's doing that. I'm gonna just continue with the a of y. So just kind of ignore it. Okay, I can't apparently. I'm just doing it in Desmos. So a of y. What the hell is it trying to do? I don't even know what it's trying to do. Control Z. Control. Oh, thank God. Oh, wow. That is not good looking at all. Okay, yeah. Is there an can I just, can I just do, hold on, let me see. No. Okay, can I just, oh yeah, I guess I can just work over it. It's gonna be the same either way. Okay. So perfectly white canvas. Okay. Yeah, just ignore how horrible that looks. So a of y, we're looking for a of y this time. Now that is going to be equal to, well, the original here, let's just start with the original equation. In this case, since a of y is not touching the angle like a of x was, a of x is touching the angle right here and right here, but a of y is not touching the angle anywhere because it's all the way over here. So a of y is the opposite because it's on the opposite side of this angle. So we're using the one that's opposite over hypotenuse. Opposite over hypotenuse. Hold on, let me turn off notifications. Yeah, there we go. Perfect. Okay. What was it? Oh yeah. It's gonna be opposite over adjacent, or opposite over hypotenuse. So that's sine O. Oh my God, my cousin's trying to call me. No. Well, I'm doing homework. Give me 30 minutes. That is adjacent over hypotenuse. Now, rework that to solve for the adjacent, which is a of y. If you rework that, then it's going to be the exact same as this one, which is you just multiply this. So now it's hypotenuse times sine of theta, which in this case is 50. So now just do that real quick. What is it here? Functions. Sine times 50 times 450 is equal to negative 118. Now, why did I get negative? Let's think about this. Why did I get negative? Did I lose right? Oh, it's cosine. My bad. Cosine. My bad. Whoops. Cosine. Okay. You should have gotten a negative because I did that wrong. Wait, no. Am I doing? No, I know I did it right. It's opposite over hypotenuse. Opposite over hypotenuse. And it is sine. What? Okay, so it's opposite over. That's 450 times 450. Opposite over hypotenuse. So you just multiply that by the hypotenuse. Sine of 50 times 450 is equal to negative 18. I guess technically you could just make it positive 18. I don't understand why it's negative. That's the thing. If you make it so, okay. Technically, this is the right answer. But for some reason, it's negative. There's a reason why, but I always forget why. Why is it negative? I don't know, but I can prove that it's the right answer. So you simplify this, it's 118.07. If you do 118.07 squared times, or plus 434.23 squared, you get this, and then if you do whatever this is, Control C, Control V, to the power of 1 over 2, which is just 1 over 2. Doing this to the power of 1 over 2 is the same thing as just square rooting it. I just didn't want to have to push the square. I just did it like this because I wanted to. You get 449.99957, yada, which is equal to 450, basically, if you round up. So this is correct. It's just negative. So, okay, if you get a negative, don't automatically assume you did something wrong like I did. Just make it positive, plug it into the a squared plus b squared Pythagorean theorem, and check that you got it right. Because again, you probably did get it right. It just might be negative for some reason because That's how sine and cosine and tangent, the functions work. They're just kind of weird like that. Now for this one, I'm not going to write it all out. I'm just going to actually do it. Okay, so is that a 58? The quality on this picture is horrible. That's a 98. Okay, let me... Okay, so that's a 98. Now, use this kind of like... I'm not really going to explain this one because it's kind of the same thing. And actually, I do need to explain one thing. So, if you remember from like algebra, a graph has 4 quadrants. This is quadrant 1. Let me do it in a different color. This is quadrant 1, 2, 3, and quadrant 4. Now, why they're split up into different quadrants? Because this is positive y. I do have mad tabs open. Deal with it. Here, watch this. If we go home, I think World of Warships. Why is this open? I do not play World of Warships. Where is it? Move to this one. So for now we go here, and now it's clean. Okay, so stop judging me on my... Stop judging me. Stop judging me from open tabs. Okay, anyway, if you remember from algebra, this is a positive quadrant. This is positive y. This is positive x. So this entire thing is going to be positive numbers. But if you come over here, this side of the x-axis is negative. Okay, so anything you get here, the x is going to be negative, but the y is still going to be positive because you still have the positive y here. Over here, though, you have the negative x-axis and then the negative y-axis. So any numbers you get over here is going to be negative. Over here, though, it's going to be a negative, positive x-axis, but a negative y-axis, because that's how the number lines work. It's like, you know, like how on a number line, you have 0, and then -1, and then over here is +1, and then, you know, 2, and so on. And over here you have -2, and then, you know, it's the same thing over here. It's basically a huge number line, and the origin is 0. Now this is important, you know, because that's kind of why you get negative numbers, like I did right here. Over here, the angle is 28 degrees, but it's 28 degrees down. Okay, so all the numbers you're going to get whenever you do this math are going to be negative, so just don't freak out. Don't assume you did something wrong. It's normal that you get negative numbers. Just get any negative number you get, make it positive, plug it in, see if you get it right. And then if you don't get it right, go back and look at your steps. Maybe you got something wrong in the math. But yeah. So long story short, because of how quadrants work, because of how graphs work in general, sometimes you're going to get negative numbers like this one right here. But that doesn't mean you got it wrong. It just means something weird's going on with math, and you kind of have to thug it out, okay? There's a whole reason why, but that's not important right now. What's important is physics. So, just draw the x and y values real quick. Here we go. This is a, first of all, let's highlight a. This is a of x. Oh, a of y, sorry, because it's the y value. And this line right here is a of x. And now we're looking for both of these. So, this is the opposite again, so we're just going to do sine of theta, which is 28 now, so sine of theta, 28, the angle, times hypotenuse, which is 98, 26, okay, so this is going to be 26, 26.55, what is it, N again? I think it's newtons. Also, I realize why it's newtons. It's newtons because this is force being applied on an object. Okay, 26.55, and then a of x right here. This is going to be equal to cosine times 28. Cosine 28 times 98. See? Negative number. But don't freak out. Trust me. Trust me, it's normal. This is going to just make it positive. Okay, so this is going to be 94, positive 94. Oh, those both look like 9s, but trust me, it's 94.34. Okay, 94.34 newtons. Oh my god. Okay. Now, if we check it, which you should always check your work, I know it's long and tedious and it doesn't make sense sometimes, but trust me, always just check your work. To the power of 2 plus, what do you call it? 26.55 to the power of 2. You're going to get this number. You copy and paste it. Control C, Control V. And then you just square root, Control V. 98.004. 98. And here, let me bring... I don't know if there's going to be any confusions as to why I'm doing this to check, but let me just explain it real quick. So Pythagorean theorem is a squared plus b squared equals to c squared. This is used in regular triangles, or a right triangle, sorry. Whenever you have a right angle and you have an angle that you know. In this case, we have an angle that we know. It's 28. And then you have one of the sides. So let's say you can measure this triangle in real life, and this is like 18 inches right here. Well, this is A, okay? This is A. And this is B right here. This is A, this is B. And C, this is a little confusing to look at. Let me pick another color. C, this is a horrible color. C is the hypotenuse, okay? Now, oh, I hate drawing on this. I'm so sorry. I swear, next time I do this, I'm gonna get a better setup. But this is, for now, just thug it out. So the hypotenuse is C. Okay, the hypotenuse is, remember, it's the shortcut basically. Forget from point A to point B. You're not trying to look for this weird, I went this far and then I went this far. You're just looking for this huge, I went this way diagonally down north or southwest. So this is the hypotenuse, and it's equal to C. Now, whenever you do this, a squared plus b squared is equal to c squared. You know, whenever you get a, you square it, and you add it to b. So this is a, remember? This here. Let me make them all different colors so it's easier to explain this. So when you get a, the green part, and you get b, this purple-ish part, and you square them and you add them together, you're going to get whatever the hypotenuse is equal to, but squared. So this is why I'm squaring a, which is equal to, remember, this is a of x is equal to, I'll try to make this a little bit easier. So this is a, oh wow, you can barely see that. This is this purple, pink. This is a, and this one's b. Whenever I got them, 26.55 and 94.34. If I square them and if I square both of them and then add them together, I get this number, which is C, but when it's squared. So if you take this number and do the opposite of squaring it and you square root it, you're going to get what is equal to C. You're going to get C, the hypotenuse, which is 98. Over here, 98. So that's why I use the Pythagorean theorem to check my work, because it's going to tell you whether or not it's right. Okay, so now that was a lot of yap. If you have any like problems with this and you want like a hand, like you want me to like be there and help you, just, you know, tell me. I got you. Let's see what this is. Select one of the depth and complexity icons from page 4 of your notebook to ponder. Think about what you just read through the lens of the icons you selected. I use the big idea, which is just the main. Hold on, let me get a bright color. I use the big idea. Wow. Just pure white, I guess. I use main idea, big idea right here. This one, because to me it's easiest because it's just the main idea. So you really just write a quick little summary and then you're done. Yeah. Okay. Well, that was it. Here are the answers if you need to check. Again, I'm gonna just run through them real quick. So for this one, a of x should be, hold on, let me zoom in. No, that's not zooming in. Here it is. So this one, okay, here it is. Okay, so here are the answers. So just so you can check, I'm not just giving out answers, okay? I wouldn't do that because that's messed up. A of x should be, which one was it again? A of x should be 94. Wait, no. Sorry. So for number 1, a of x should, or number 1, this graph, because they're not numbered. For this graph, a of x should be 434. Let me write it in black. A of x should be, what the hell, I just pushed black. Hey, 4. What the hell, man? What the hell? What's going on, man? 434.234. And a of y should be this one, 118, or negative 118. Wait, no. Yes. A of y should be 118.07. Okay? That's what you should have gotten. Like, officially. I proved it. If you did not get this, you did something wrong. Because I proved that it was right here. And then this one, ignore all this. This is, but here are the correct answers. For a of x, you should have gotten 94.34, and a of y should have been 26.55. And like this one over here, I checked these. I proved that they were right. If you do not get these, you got it wrong, okay? If you got something close to it, you didn't get it wrong. If you're like 2 numbers off, like if it's 24 instead of, obviously you just, you do something different. But yeah, so these are the official answers. Like this is correct. If you do not get this, you do not get it right. Okay. Yeah, but this was my first attempt at this weird like style of tutoring. If you need help with like doing it on a TI-84 or like that one app that we use, the TI-84 app, find me in person and I can help you with that. If you need any help with this, like if you need me to explain a very specific question, again, find me in person. And if you don't go to Singly and you're watching this randomly, don't find me in person because that'll be really weird. But yeah, okay. Now I'm gonna go do Miss Ring's homework, and yeah, maybe I'll make a summary of that too. I don't know. Bye bye.